Hello everyone. Today is the 75th day of Leetcode 75 challenge. Let's begin with the 75th question. Question 901 online stock span. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So you are given a stream of daily stock prices where each call to next price provides the stock price for the current day. For each day price, you want to determine the span of stocks price for that day. Okay. The span is defined as the maximum number of consecutive days starting from today and going backward, where the price was less than or equal to today's price. So, what this basically means is that you are given two functions. Okay, first is this, and second is this. Stock spanner initializes the object, and next it provides you the price of the stock in that particular day, right? And this will also return the span of today's price. So, suppose if some prices are there, x1, x2, x3, whatever, right? And today is some x4 price. Fine. Now let's focus on this thing. So they're trying to say that a stock span is basically if today is x4 price, we have to go backward and look when was a price which was less than or equal to this price. Suppose this price is less than this x4, this is also less than x4, but this is equal to x4, but this is greater than x4. So how many what is the stock span then? It's 4. Why 4? This 3 plus 1 including the current one. Like if you can see the point number 4, if today's price is greater than or equal to previous day price, the span increases by combining consecutive days with smaller or equal prices. Okay, this we understood. If today's price is less than previous price, then the stock span is today's is 1. So basically if x4 and this is x3, if x4 which is today's stock price, if it is already less than this before price, then this becomes only 1. Its stock span is only 1. Got it? So in simple layman terms, if you try to understand, if suppose a stock span is given to you and this is the current stock span, right? You just have to figure out when was the stock you brought was less than or equal to this price. Okay. Suppose in this day you brought it at rupees 20 and today it is suppose 60, right? And in between it was 5, 10, basically less than all the numbers less than 60, right? So this will be your stock span. When you got a profit, you can understand in that way. Fine. And if today, now let's see this x4, right? If today is 10, right? A price before just before this is 20. Then if it is 10 or 5, it does not matter. That is not a stock span, right? It has to be continuous. So that is why for this the stock span becomes 1 because 10 is smaller than 20, right? So I hope you understood this particular thing, and we will understand it much more in further slides. So the constraints of the problems is the price which is given to us could be from 1 to 10 to the power 5. At most 10 to the power 4 calls will be made to the in next function. Fine. So I hope you understood the problem explanation and the constraints. Now let's move to the next slide. Now let's understand the input output explanation. Okay. Now let's understand this from this taking this particular scenario, right? So first is stock spanner. The class is initiated, so it's empty. Never mind that, right? So that is why that is null. Okay. Let me write null here. Fine. Then it is 8. Then it's 100, right? Suppose before 100 you didn't brought anything, right? So it's the first stock you brought. So the stock span for this will be 1 definitely. Fine. Then it's 80, right? So you bought the stock. Today's price of stock is 80. Suppose, just suppose. So if you bought this stock, you're not getting any profit, right? I'm trying to make it understandable in the practical manner, right? And before this, it was 100, right? So you didn't make any profit. So this is your new stock span, new stock, right? Satisfy 1. Let's understand this way. Then it's 60, right? Then it's 60. Again, you bought a stock. Let's suppose you bought a stock, but this stock is not greater than 80, right? We don't have to look at 100 because it is not even greater than 80. Then it does not matter whether it is 100 or 20 before that. Fine. So this is your new stock span. So new stock span starts from here. So from here you might make a profit, right? So that is why 1. Then came 70, right? Then it's 70, right? Now suppose you bought the stock at 60, right? And you sold it at 70. So there is a profit and it's a stock span. So what is the stock span here? 2. You have to include this 70 also. But if you try to look from 80, it's not possible because it is greater than 60 and it is greater than 70. If it might have been 50, you might have included this also, which means you brought it at 50 and sold it at 70. I hope you are getting this practical explanation. So it's 2, right? Then comes 60. Now look here itself. Suppose it's 60, right? Before 60, it's 70. So again, it will be the same scenario because this is the new stock span for you, right? So it will be 1. Then it's 75. Then 75 is greater than 60. It's greater than 70. It's greater than 60. So understand it that way, that you bought the stock X at particular day 60 and you sold it at 75. So you made a profit. So it's a stock span because everything is less than 70 continuously. It has to be continuously, right? So it is how much? 4. Then comes 85. Again, the same scenario. Suppose you bought this at rupees 80 and you sold it at 85. So how many stocks are there in between? 1, 2, 3, 4, 5, 6. Right? That is the output here. 1, 1, 1, 2, 1, 4, 6. Right? So I hope you understood the input output explanation. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. And let's build it by understanding the goal first. We are given a stream of stock prices where each call to next price provides a today's price. So basically, next function gives you the today's price. That's all. And from the today's price, you compare the stock span. For each day, we want to compute the stock span, maximum number of consecutive days, including today's. It has to be consecutive. Please keep that in mind. Such that the price was less than or equal to today's price. If the price today is smaller than yesterday, then the stock span is 1 because, as we saw earlier, if 20 is the previous and 10 is today's price, so you cannot create a stock span. But if the price today is greater, like this, if it is greater, then you might create a stock span. A brute force solution would be, what would be a brute force? Let's take this example itself. If you can see 100, it was then 80. I hope it was 60. Then it was 70. Then it was I guess 60 again. Then it was 75. I guess then it was 80. I guess this was the thing, right? So if you have observed, this is a sin 100, right? This is 80. So brute force could be you can stand up at 80 and you might go back, right? Let me write it properly. Suppose you stored your values, right? Suppose you came to 60 and you stored this 100 to 80 in an array or somewhere, right? And you're standing here. So what you can do, you can iterate back and check for the values which are less than 60. Similarly, you can do with 80 also, correct? Similarly, you could do with 70 also. Again with 60, again with 75. So O of n time complexity will be taken to traverse this complete list, first thing. And another O of n in worst case will be taken to for the comparison. As we can see here, the eyes are going back, right? From if you're standing at 80, right, you will go back again to check for the values which are less than consecutively than 80, right? So that is why the time complexity for that becomes n square. So a brute force approach would check all previous days for every new price, leading to an inefficient n square time complexity. So you could start with this time complexity, but we have to look for a much better one. Okay. So before moving ahead, I want to let you know about monotonic stack. Right. In my previous video, also I have explained this. What is a monotonic stack? But let's go with it. So there are 4 kinds of monotonic stacks. One is next greater element. Second is next smaller element. Third is previous greater element. And fourth is previous smaller element. Right. These are the 4 kind of monotonic stack. And what this particular means that if you have a stack, the stack will only store from a list, given list, the next greater element. Suppose if it is 100, right? So 100 will be stored here. But next element will not be 90 in the stack. No, it will be 101 or greater. So this will keep on increasing. Similarly, next smaller. So if it is 100 in the list, the next would be 90, not 101. Get my point? It's 100, then it's 90. The next smaller elements is 80. So it will kind of this. Similarly with the previous greater and previous small. So this is a monotonic stack is, and we will be using this particular concept of monotonic stack in our particular problem. And why I concluded this with a monotonic stack? Reason being, in this particular problem, if you have observed, what we are doing, if I are iterating and we are standing here, we are going back, correct? If I is standing here, we are going back. If I is standing here, we are going back. We are again iterating the same scenario. But for this particular thing, if you already know the answer of this previous part, it will be easier to calculate, correct? So in this kind of scenarios, when where we have to go back and forth again and get the repetitive values, in that kind of scenarios we should use stack first and foremost. And by looking at the pattern, it comes out to be a monotonic stack. Okay, because in here we can observe that in this particular problem, that we are always trying to look for smaller elements by going backwards first thing, and we were storing only the greater element, right? So this problems boils down to a next greater element. Okay, now let's visualize this process. And before going to these points, I will just give you a proper intuition. So let's move ahead. Now, since we have already boiled down that this is a problem of a stack, correct? And it's a monotonic stack, which will be next greater element, correct? So let's see how it's a stack. Okay, that's understandable. How it's monotonic stack, let's look at it. So we could call it as next greater element concept, or if you want it more to be a clearer version, we can call it as a previous greater also, right? That I will explain you. Okay, let this be a stack. This is a stack. Now let's start with 90. Okay, so I just placed 90 here, and span for this 90 will be what? It will be 1, right? For one element it's always 1, correct? Then we are standing at 95. Okay, the span for 95 will be 1 till now. So we can see that. Let me write it also somewhere. Let me write it here only. It's 1. Fine. For 95, we can see that previous value it's 90, correct? And it is smaller than 95. So what will happen? We will pop this value plus 1, the stock span of the 90. So the stock span for 95 becomes 2. Okay. So what will happen? 95 with the stock span 2, and I will write it here 2. Fine. Then comes the 85. 85 is already smaller than 95, right? So the stock span for 85 will be 1 itself, correct? Then we come to 88. We can see that 88 is greater than 85, right? So what we will do? Stock span of 85, which was 1, plus the stock span of 88, which is 1, becomes 2, correct? And 95 is greater than 88, so we cannot go much further. So that is why 88 with stock span of 2. Fine. Then comes 100. Fine. The stock span for 100 is 1 initially, but 100 is greater than 88. Also, it is greater than 95. So we'll pop both of them. So we'll pop both of them. And since there each stock span was 2 plus 2, so 4 plus 1, 5. So there is 100 here with the stock span of 5. Then comes 70. Now 70 is smaller than 100, so the stock span will be 1 only, so 1. Then comes 80. Initially stock span is 1, but we have 70 with stock span 1. So it adds up and it becomes 2. Correct? And we will pop this 70 also and push back this 80. It's stock span of 2. So this way our complete iteration is done. And here what we observe, that if you look it from top, it's always a greater element. Fine. What happened? We're looking for the next greater element, right? Makes sense. But when we are looking for the back, we're looking for the previous greater element, correct? If you look it from the back side, we're looking for the next greater element. For 90, we're looking for 95. But if from 95, from suppose from 100, if you're trying to look, we're looking for the previous smaller element till we get a previous greater element, then 100. Like for 88, previous greater element was 95, right? So if you look at this particular stack, it's basically looking for previous greater element, right? So this is what our stack looks like, previous greater element. But if you look through this list, it's a next greater element. But our stack is monotonic with previous greater element. Fine. And if you come back, what I explained here about this next greater element, it's what about going through the list. But the stack, the monotonic stacks which we are creating will be a previous greater element. Fine. I hope you understood this, why it's a previous greater element in monotonic stack. Now let's look at these points what I've written here. We use a monotonic stack to keep the track of pair, price, and the span for unresolved days, which we were doing. When a new price comes in, while the top of the stack has a price less than or equal to today's price, we popped it and adds its span to today's span. Otherwise, we stop because the stack is strictly decreasing in price. We saw this, right? And we popped until and unless we get the smaller element, right? Until and unless we get the greater element, then the one which we are going to push into the stack. And why we are using stack? It helps us to skip over multiple previous days in one step instead of going one by one. Because what we are doing when we pop this, right, we store this span with along with it 80 span and here. So when a new element comes which is greater than 80, so this element will know that okay, we have already looked the values which are smaller than 80, so that value will also be smaller than the value which has arrived or which is greater than 80. Got it? So this is the example we looked at. So how we can simulate this? So look, in Python we directly don't have any stack function, correct? So what we do, we use list as a stack. So to pop it from the back, what we usually do, we do stack minus 1 gives the last element or the top element of the stack. Fine. And when we do 0 or 1, this will give, since we are storing price and span, if it is 0, this gives the price. If I put 1, it gives the span. So if you look here, if we initialize the stack with price and span for each element in the loop, we set the span to 1, then we check whether the stack is empty or not. If it is not empty, then check that if the stack stop value minus 1, 0 means price. So it's basically price. If this is less than or equals to the price which we have got now, that means we have to pop it, right? And when we pop it, then what we do, in span we add stack minus 1 1, right? Because this is the span. And after that we push it into the stack when the while loop is ended, and we return the span after the for loop is done. Now what we figure out, we figure out that a brute force approach checks all previous day, which is too slow. N square solution, we notice that if today's price is higher, we don't need to recheck each day, we can jump over blocks using their spans, which basically means when we accumulate span, suppose 80 has a span of 6 and we got 100 here, so we don't have to go all the 6 values which were behind, 5 values which are behind 80, right? Because those are not in the stack first of all, and we have already calculated their values here. So this leads to storing price span, so we can skip multiple days at once. So from 100 we can directly go to 80, which is the next, just the top element of the stack, and we can increase 100 to 100 and 100, 7. Got it? So a monotonic decreasing stack, or you could say, yeah, there are multiple ways. Decreasing means why? If we look this way, 100, then it's 80, then it's 70. So this way it is decreasing, correct? And I know it might be confusing. And when we say previous greater element, if we looked at the list, if you're standing at 80 and till 95 it is smaller, so we're looking for previous greater element, correct? And if we look it from the starting to the next, it's the next greater element, we're looking for the next greater element, so that we can pop it from the stack. Suppose if it's 80, 70, then 60, then it's 100, right? So these all are added to the stack, then it's 100. So we looked for the next greater element. Now this will look for the previous greater element, suppose 101, and it will pop all of this, right? And the stack becomes kind of a decreasing way from bottom to top. So I know this is kind of a confusing thing. So if we just focus on the problem and boil it down, it will be just a previous greater element. Just focus on that. And why focus on that? Because to be very precise, we are just looking for the previous element from the current one. That's it. Okay. I've written these 2-3 terms here just to make it much more clearer so that you can explain the interviewer. But to be more precise and accurate, it's just previous greater element. And why it's the last time? Because if you're standing here, we're just looking for the previous greater element. That's it. Till that time, we'll pop all of this from the stack. Got it? And in the stack, we will be only storing the previous greater elements only. Thus, each price is pushed pop once, giving an efficient solution. Fine. So I hope you understood the intuition. Now let's move to the next slide. Now, since we got the intuition of the problem, let's look into the approach how we're gonna solve it. Step one is initializing tracking. Basically, stack. That's it. The stack keeps the track of the previous, and this will be done in the I think this function name was stock span. I guess so. In that, it will initialize the object that particular function. Now, step two will process each price. So in the next function, we will have span initialized for this particular element, which is passed in the next function, and we will iterate with the same condition given here. Okay, and at the end we will return the span. If today's price, so this is we already know, so we don't have to read it again. So I hope you understood this part. Okay. At step three, final result, right? After doing the calling the stock span function, then calling the next function which accumulates every results and just returns it, right? That's the step three. That's it. So I hope you understood the approach. It was pretty straightforward and simple because we have already got the idea of the code and the flow of it, right? So let's move to the next slide. Now the code is the exact copy of the approach discussed. Let's understand it line by line. So this is the initial constructor. You could call it as constructor, and here we initialize the stack, and then the next function which is given to us. Here we will just include the span, while loop, looking for the condition. If it is true, add the span and pop it. Keep on doing it until and unless it becomes false. And after that, coming out of it, just push it into the stack and just return it. That's it. And the time complexity for this is O of n. Because let me explain you, it's a bit tricky one. If you have observed the complete code and the intuition, the elements, one element is pushed one time, correct? And one element or each element is popped one time, correct? Hence, total operations becomes O of n plus O of n. So it's 2n. So O of n at the end, correct? It's not like that if you have pushed one element, correct? Then you go ahead, you pop it, then you come back, then again you push it. I don't think this is happening. This is not happening. We're just pushing the values in the stack, we're just popping it. That's it. But we are going iteratively ahead, right? We're not going back in the main iteration. That is why the time complexity is only O of n, not O of n square. Right? Again, if you might have a counter question that we are using while loop, then why it's not an n square? Because man, if we are just popping the particular value once, right? Do we push that x value again into the stack? No, right? Once it's popped, it's popped. That's it. That's what I gave explained here. Once pushed, once popped, done. But again, if you go back and push it, the time complexity raises to n square. So that is not happening here. Got it? That is why the time complexity is O of n, and space complexity is O of n for the stack space. Got it? So I hope you understood this code explanation along with time and space complexity. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. Okay. So I have also brought down the code here for a better understanding. So let me initialize a stack here. Okay, let this be the stack and let this be the output array. Fine. Let me join this. Fine. So let's start. Fine. So we start with 100 here. Correct. Span of 100. Let S be the span is 1. Then stack is empty, right? So nothing to be done. Just append the value 100 comma 1. Correct. So the output for this will be 1 because we return the span for this particular 100. Now 80. Now 80 is passed here. Goes this way, right? So every time we have to return the value. So span for 80 is 1 again. Stack is not empty, but the stack topmost value, it is now less than or equals to 80, right? So we will come here add 80 with a span of 1, and we return the span. So span of 80 was 1 again. Fine. Now 60. Now 60 is passed to this function. Span for 60 becomes 1. Stack is not empty. Topmost value is 80, right? And 60 is not greater than 80, right? So we come here, we add 60 into our stack, and we return the span of the 60, which is 1. Now comes 70. So 70 is passed. Again, span of 70 remains 1, and stack is not empty, and 70 is greater than the topmost value of the stack, which is 60, right? So what we do, we take the span of the 60 topmost variable and add it, and we pop it, correct? So this is done. Because 80 is greater than 70, so that cannot be popped. Of course, the case will become false. So 70 comma 2, and we return its span, which is 2. Great. Now comes 60. So now it is 60. Stack is not empty, but the topmost value is 70, right? So it is not less than 60. So what we do, we just push 60 here, append with the stack span of 1, right? And we return the span, which is 1. Then comes 75, right? So what we do, span is 1 for 75, and the stacks is not empty, and the topmost value it's 60 and it is less than 75, right? 75. So simple, we will just take its span and add it, correct? Then 70 is also less than 75, right? So we will pop this also, add its span, which is 2. But 80 is not less than 75, correct? So it stops there. So what we have uh, 75 with a stock span of 4. So we return 4. Okay. Now comes the last element, 85. Stock span is 1 already, and the topmost value is 75. It is less than or equals to 85. Yeah, true, right? So we take its span, which is 4. We pop it. Again, we check it's 80 smaller than 85. We take its span and add it, correct? But it's 100, right? So 100 is greater than 85. So what we do? We come here and we push it. We push 85 with the stock span of 6 if we add it, and we return the span of 85, which is 6, right? And then the iteration is complete. And if we match this output with this, is it's same, right? 1112146, 1112146, right? So I hope you understood this dry run. And if you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, the approach, and the code, and also about the monotonic stack. And after that, do a dry run by yourself for 2-3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. So now let's move to the next slide. Now, since we are familiar with the problem and the solution, let's move to the Leetcode and code the solution. So let's start by initializing the stack first. Self.stack. Fine. Great. Now let's initialize the span for each day price. Now, while self.stack, if it is not empty, and self.stack last value or the topmost value's price, if it is less than the price of the day, then just add the span of the topmost value of the stack, and self.stack dot pop the last value or the topmost value, self. Fine. And after that, self.stack dot append the price with the span and return the span. Let's try submitting for the sample test cases. Now let's finally submit our solution. So we have successfully submitted our solution. Now code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.